Thank you very much. I haven't even said anything yet. You're already clapping, so that's a good sign. As you may have heard, I have enjoyed my stay in Paris in my hotel room. Beautiful view of the river, boats, and that was about it so far. So my power gauge was down to maybe 15%, the red flashing one. And now I'm probably up to about 60. So we'll see how this goes. And I think I'm probably not going to collapse on stage. But wouldn't that be a great story to be able to tell? So I'm not going to stage it. If I do collapse, I'm actually collapsing and do come up. But here we are. I want to start by dedicating this talk to my friend Barry Dwolatsky. He was a professor at Wits University, and he passed a couple of weeks ago. I didn't think I was going to get this emotional about it, but we have a long history in computing, and we tend to forget it and ignore it. But in fact, there are giants that came before us that give us examples of how to act ethically in our profession. And Barry was one of those. So if you want to know more about why I'd get this flustered about it, he recently finished his memoirs called Coded History. And I'll just finish at that. More caffeine. That's going to work. Okay. In 2005, I was invited to sit on a panel celebrating the 25th anniversary of a book called Structured Design by Ed Jordan, another one of those giants, and Larry Constantine, who's also one of the giants, but he's unfortunately still alive. And so this book, Structured Design, how many of you have seen Structured Design, the book? Okay, green book, quite intimidating. So I'd had it as a college textbook soon after it came out. And so to prepare for the panel, I thought I should probably read the book because it was my college text, so I never read it, and the parts I did read, I certainly didn't understand. So I started reading this book, and I realized, oh my goodness, the equivalent of Newton's laws of motion for software development are contained in this book. This is the book that introduced the terms coupling and cohesion. And turns out that the definitions of coupling and cohesion in that original book were very, very clear. They've since diffused and become less clear over time. But I thought, oh my goodness, we should... one of the problems with the book is it's dated. There's a lengthy conversation about assembly language versus these new higher level languages. Should we use them or not? There's examples that use paper tape as part of the design. I thought, boy, I vow to take this material and bring it into the 21st century so that other people can make use of the concepts that are here and do a better job of software development. So I felt confident in my abilities as a software developer, as a software designer. I'd come up with designs that seemed to work well, but I couldn't articulate exactly how I did what I did. So that book helped me be clearer about that. Got up on stage, did the panel with Ed, with Larry. I think Grady Booch was there, maybe Rebecca Werfsbrock. And, these old guys up there, you can understand how they might be slowing down a little bit. No, they slaughtered me on stage. Part of the beauty of panels is you get the interaction between the panelists and new stuff comes out. And, oh, God, they were so sharp. So that was a humbling experience, but only temporarily. And so I started working on how am I going to bring this material into current frame. And I made some progress on it, but I got stuck pretty quickly. I can define coupling and cohesion in their original terms, but I couldn't explain why. Especially, I couldn't explain why cohesion was the way it was. And I kept trying. And the only way to learn how to explain something well is to explain it badly over and over and over. This requires patient friends. But after a while, I wasn't making more progress, so I thought, all right, fine, I'll just let this go for the moment. One of the themes of my career is that I just don't let go of problems. I've got a backlog of 20, 30-year-old problems sitting back there, and every once in a while, in the middle of the night, I'll wake up and I'll chew on it for a while, and no progress, and I put it away, and fortunately, I have a large backlog of those kind of problems. So this was just going to go into that backlog. And about 4 years ago, I unexpectedly had 2 weeks free up in my schedule. And I thought, you know what? I'm just going to try to write this book that I've been meaning to write. I've been nibbling around the edges. Let me try and just write this. And I sat down and I opened up a document. And the first sentence off of my fingers was, software design is an exercise in human relationships. And I thought, what? No, it's about coupling and cohesion and about power law distributions and about, semantics preserving transformations, and this can't be right. Software design is an exercise in human relationships. Oh, God, what in the world does that mean? So that was 4 years ago. I think I'm starting to understand what that means. So what I'm going to talk about today is what I've discovered in my career as a software designer, and then in the 18 years since that 2005 panel, what I've discovered about explaining software design. It comes from a blog that I have called Tidy First, and I'll explain what Tidy First is all about in just a minute. And this is as far as I've gotten. The blog is going to turn into a book, actually a series of books. Should be out from O'Reilly when I finish it. This isn't on them. This one's on me. It's not that I write slowly when I write. It's that I spend so much time not writing at all. That's what slows me down. So anyway, I'm a certain ways there. The first thing that struck me once I was confused by what I meant by software design as an exercise in human relationships, the first thing that struck me is there's a big divide between two kinds of activity as programmers two kinds of activity that we do, and I don't think that distinction is made clearly enough. So there's one loop where we have an idea for some sort of feature, and then we change the behavior of the system. So, I need a button that does blah, 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 and then da-da-da-da-da, and then there's a button, and it does the thing. And one of the beauties of software development as an activity, I mean, we're engaged in this incredibly leveraged process where the work we do can affect the lives of millions or potentially billions of people. I mean, there's some downsides to that too. When I spent 7 years at Facebook. Sorry about democracy. Whoopsie. But it's also, when it works well, it's really cool. And one of the things about it is every time you develop something, you get ideas for other things that you could develop. Some of which you have time to do and some of which you don't have time to do. But this is the basic loop of software development as a kind of an economic activity. You have some ideas, you change the behavior of the system, you get more ideas, you change the behavior of the system. And one of the things we know as developers is this is not the whole picture. There's another area under the surface, and that is the structure of the system profoundly affects how easy or hard it is to change the behavior. And if all we do is live inside this loop, give me an idea, I implement it, have more ideas, implement it, hurry up, faster, faster, faster. Like, I want to implement all the ideas because we don't know where the value's coming from, so let's just try everything. There's always going to be more ideas because there is fan out here. Anytime you implement one thing, you're going to get ideas for 3 more things to implement. So the idea that this is why backlogs are a bad idea. Because they're going to grow exponentially. And if they're going to grow exponentially, it gets harder and harder to make priority decisions. And backlog grooming becomes an exercise in... it's kind of like curating a museum. You just add to the collection, but the more you add to the collection, the more stuff you have to preserve. And the more stuff you have to preserve, the less stuff you can put on display. And you're in this inhibiting loop. Anyway, so we've got this primary loop that's visible to everybody on the outside, but we also know that sometimes the quickest way to get to some new behavior is to go through structure first. We say, well, it's hard to implement this button. Why is it hard to implement? Oh, because of the structures, and if we blah, 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 then it would be easy to implement the button. So we're going to change the structure first, then we're going to change the behavior. And that can be cheaper than ignoring the structure and just changing the behavior directly. Water. Or vodka, whichever. I'll take it. Yeah, the good stuff. Now, if this was easy, regular people could do it, right? It's much more complicated than this, because sometimes you change the behavior and you go, oh, I thought that was going to be easy, and it turned out to be hard. Because the structure is So let's fix the structure so the next time we need to add something, it'll be easier. And this is one of the beauties of software development, is when the structure of the system starts generating ideas on its own. So sometimes you're like having beers with the product person, and the product person says, oh, I wish I could implement and you say, well, I just did a refactoring and that would be dead easy to implement. Really? That would be cool. So sometimes the structure itself suggests ideas that go into this loop. And those ideas can be some of the most powerful, the most valuable ideas. They require an understanding of the structure, which as geeks we have, because that's what we live with every day, and which no one who doesn't live inside the guts of the system could possibly understand. So what we have here is an incredibly valuable picture, this cycle. If you look at the profitability, and I'll oftentimes talk in terms of profitability and economics today, and that's not all I'm talking about, but it is part of what I'm talking about. I think there have been times in my career when I've been focused on truth and beauty to the exclusion of other things, and that only goes so far. At some point, somebody's going to want to make money so that they can keep paying you. So it's not just about money, but it is also about money. So this is an extremely profitable picture, and it scales very nicely. As I said, sometimes it can scale to billions of people, which no other activity in history has done, except maybe your religion. Okay, I need to follow up on that one later. Okay, and now we can start talking about to what degree are we talking about human relationships here. We can make a distinction here between the sponsors or stakeholders. I don't know what the right word is. Users care about changes to behavior. Investors care about changes to behavior. Marketing cares, sales cares, customer service cares. They all care about these changes to the behavior. Operations cares, because that affects their lives very directly. And what I'm going to call changers, the geeks, the folks who live with the structure, they care about behavior, sure, but they also care about structure because the structure affects them very directly. And this is a fraught relationship. Always has been a fraught relationship. One of the things about being around in software development long enough is you get to see stuff come back around and then come back around and come back around again. It can be challenging at times not to go, oh, this again. But one of those, I saw somebody quoting extreme programming saying, extreme programming is intended to heal the rift between business and technology. There's this chasm between them, and extreme programming is a bridge to go between them. That's exactly the same relationship. So now I'm having the opportunity to address that same thing. Why is this relationship fraught? Because the incentives short term are divergent, strongly divergent. It seems as if you could say, well, just ignore the structure, just work harder and give me the next feature, and we'll be like everything will be better. Let's just ignore structure. We'll just look at behavior and we'll get more of what we want. And it seems like that to sponsors because they're not seeing the day-to-day. They're not back in the kitchen. One of the analogies I use is is the kitchen. They're not in the back of the house. Well, if you stop wiping your knife, you could slice things faster. Yeah, but our diners are going to start dying of food poisoning. Yes, but they'll get their food sooner. Well, it seems like a trade-off that you wouldn't want to make, not if you put it that way, but that is the equivalent to what happens all the time in software development. So this is a human relationship between sponsors and geeks, the changers, the people who can actually manipulate the system. Now, as geeks, we, and I'm projecting, but it's not a big stretch, are not great at those relationship skills. Not naturally good at it. Turns out they're learnable skills, and it is possible to learn how to not be horrible at relationships. That's my bar. I just want to not be horrible at it. So it is possible to maintain these relationships, but it's also possible to remain horrible at it. And this picture is a place for these dysfunctions to play out. So typical geek reaction to this would be to say, either, okay, I'll just keep adding features as fast as I can, and I'll ignore the structure, which is getting worse and worse and making my life worse and worse because I'm getting paid to program, and that's a great thing. It is a great thing. That's not all there is to it. So that's one side. It's not sustainable, and we know it's not sustainable, but we do it. The other side is for the geeks to, I didn't realize why I wore the suspenders today, but this is the moment. I'm in charge now. I can insist on spending all the time on the structure that I want. You're just going to have to wait. We've been adding features for the last 6 months, and now we're just going to stop everything and work on the structure for 6 months. And that only lasts so long because that story, hey, I want to go work on the system for 6 months. You're not going to see any changes. At the end of it, it'll be exactly the same system that you see today. Not a compelling story. And it doesn't work because it's not good for the relationship. It's not good for either party, for the geeks to be separated from actually delivering visible value for 6 months at a time. It's also not good for the geeks to never get to work on structure. So how can we find balance between investment in structure and investment in behavior? I think the geeky intuition is too much of the investment goes into behavior and too little goes into structure. That's the kind of, if there's a general worldwide phenomenon, and then every once in a while the geeks are in charge, and then there's this stupid amount of investment in structure, but it's a self-correcting problem. So how can we bring investment in behavior and investment in structure more into balance so that we can maintain this relationship between sponsors and the changers of the system? That's the challenge. Now, it turns out there are other relationship challenges here. One is that the changers don't all see the system the same way. So if we're on the technical side of the team, and the four of us are working together, and I'm providing some API to the three of you, and I decide I want to change that API because it's better, because it's GraphQL, mystical, magical, whatever. Today's brand of fairy dust. I really do get kind of cynical sometimes, but whatever. I also lost my hair. Nothing I can do about either of those things. So we have relationships. Now, we're all geeks, so the special relationships. But we can still piss each other off. We can still damage each other's work. I can say, well, I changed the API and I've deprecated the old one, and you all have to change your code. Well, why? I'm just the provider. You're all going to have to go spend however long changing things. And if it doesn't fit your needs, well, too bad. This is not a relationship building move. As a software designer, you're responsible not just for getting the bytes right, but for maintaining the relationships as you do so. So if we have an API between us and I want to change something, I have a responsibility for helping you upgrade the code to the new API, to adapt to the changes that I'm making. My job is not done when the bytes are correct. My job is done when we're back to hating each other about the same amount as we did before. Then I'm okay. There's another relationship that comes as I started writing. Now, the process of writing a book always, for me, always starts with, I think of an idea. I think there's no way that I could write a whole book's worth of material about this. And then I start working on it. I realize, oh my goodness, this is like 6 books. Which tiny slice of it could I possibly, and then I pick a tiny slice of it. And then I start working on that. And I think, oh, there's no way that I could write a whole book's worth of material on this. And then I get ways into it and I think, oh, this is like 6 books. Which tiny slice of it? And then I keep doing that. And eventually I get down to something that I can actually publish a book. It's not going to be thousands of pages. So that happened to me. I started out thinking, I'm going to focus on this diagram at this scale. And then I worked on it for a while, and no, it was way too big. And then I thought, all right, teams designing together and these kind of fraught relationships. No, that's way too much to start with. And what I realized is these changer-to-changer relationships cannot be healthy until changers have a reasonably healthy relationship with themselves. And when I go around and I talk to programmers, what I see is that programmers don't have respect for their own work and themselves in their own work. Oh, we have this horrible long tool chain and I just have to live with it. Nothing I can do. It's a kind of masochism. Sometimes it feels a little bit like ritual scarring or something. Like, just see how much pain I can endure to be a programmer. Aren't you impressed? No, in fact, if you chose not to feel pain as a programmer, that would be impressive. And there's a particular moment that happens to every programmer 10 times a day that's emblematic of this relationship with yourself. So we have to change the behavior of some code. And we can be talking about, I have a single test case and it's failing and I need to change. And the code's kind of messy. This is going to be hard to change because I have to change this and this and this. And then the test case is going to pass. Should I tidy first? And the answer is sometimes yes and sometimes no. I mean, there's the dogmatic answers, both the no, you shouldn't tidy, you should get to work. Because after all, life is pain. And this is part of life, so it should be painful. That's the there's one dogmatic answer. The other dogmatic answer is, of course, an artiste such as myself. I have a vestigial hair flip. I can remember when I had flowing blonde hair, and I can still, my neck knows how to do that, even if my hair follicles have forgotten. So between those two, there's a middle ground. I need to change the behavior of the code. The structure is not helping me. The structure is hindering me. Do I tidy first? And the answer is, now you don't have to buy the book. Probably yes, just enough. But what are the factors that go into that decision? It turns out it's all the factors that go into all of software design at every scale, which makes this a kind of fun place to start discussing software design, because I can talk in miniature about the kind of factors, the kind of economic factors, the kind of psychological factors, the kind of technical factors that affect every design decision. And they come out in this kind of miniature form. But where it starts is your relationship with yourself. Like, this is the third time I've edited this, and it's a pain every time, and I make mistakes every time. Okay. Is it time to move to structure just long enough? Now, one of the problems with moving to structure is it feels so good that you want to just keep doing it and keep doing it and keep doing it because it still feels good. And you never have to face the rejection like, okay, now the feature's done and the users use it and they hate it. If you just, I've got this big, long function and I pull out some helpers and I find some common helpers that make it simpler, and then I extract a method object out of it, and it just gets simpler and simpler. It's addictive and seductive, and at some point you reach diminishing returns. So, but if you don't value yourself, you'll never even get started with that process. You'll just think, oh, I have to change this again, and there's nothing I can do about it. This is never true. There's stuff that maybe you shouldn't do about it, but like you're the programmer, you could decide to try this. So, where are we on time? Okay. What am I throwing out? I promised I'd tell you about coupling and cohesion, so I got to do that. Let me talk about I'm starting to come up with a coherent philosophy of software design out of this. And part of that is an observation that I call Constantine's equivalence. So Larry Constantine was one of the early people at IBM, wrote structured design, has been a mentor to me, has done some great work in user experience since then. He made an observation in that structured design book, which was based on looking at a bunch of programs written at IBM. He said, well, people want to minimize the cost of software development. So the cost of software development, back in the day, the impulse was let's make the initial development as cheap as possible. We're going to work really hard to make initial development as cheap as possible. That's how we're going to reduce the cost of software. And he said, nah, because the cost of, you're always changing the software. Always, always, always. So the cost of developing the software is approximately equal to the cost of changing the software. that initial development period is an illusion. If you're successful at software development, the software is going to live 10 years, 20 years, 30 years, 40 years. And whatever you spent on it at the beginning, sure, it seemed really expensive at the time. It is an insignificant fraction of what you spent on changing the software over time. So this automatically changes our approach to development. We're not going to try and put all of our efforts into making the first release perfect, because it's not that it just isn't. It's that if we release the software and it's at all successful, the requirements for the software are going to change. The act of releasing it changes the requirements, which is why the waterfall is such bullshit. And it's back, but that's a whole nother conversation. So we're making a bunch of changes to the software, and then the second thing that he noticed when he looked at real projects was that not all changes were the same size. Some changes were small, and some changes were big. And if you add up the small handful of really big changes, and you say, how much do we spend on those? It turns out to be a large fraction of what you spent on all the changes together. So the cost of change is about the equivalent to the cost of the big changes. And I can go into arbitrary amounts of detail for why this is. What happens, those big changes happen because I need to change this. Ooh, I need to change that and that too. But if I change this, I have to change these things. And if I change that, then I have to change. And it's like an avalanche. It's when one change triggers several changes, which trigger several changes. This gets especially expensive if you don't notice. Where I change this part, I should change that part. I don't realize it. I put it into production. Now I've got to make these changes in an even more expensive way, which may themselves trigger further changes, and so on. And if we were to draw the graph of all of the elements in our system, say that we have 1,000 functions in the system, and if I change this one, then I have to change these. And if I change this one, I have to change these, and this one goes to here. I can graph this propagation of change. But what is this relationship between the elements? And that is exactly coupling. So the cost of these big changes is the cost of coupling. Coupling is defined as 10 minutes, come on. Coupling is defined as for two elements in the system and a change you need to make. So it's those three things together. Say, if I change this function in this particular way, I have to change that function too. So if I have a caller and a callee, if I change the name of the callee, then I have to change the caller too. And if that function is called 1,000 places, I have to go change 1,000 places, and that's a very expensive change. So coupling is this relationship between elements in a design where if I change this in a certain way, I have to change that too. So if you want software development to be less expensive, you have to reduce the coupling in the system. Now you're in a trade-off space. This is the international symbol for trade-off. I don't know if you knew that. You're in a trade-off space where we have the cost of coupling on one side of the trade-off, but we have the cost of decoupling on the other side of the trade-off. You can eliminate some coupling. Other coupling you can't, or you don't know how yet to eliminate it. And so you want to be in some balanced state, someplace close to the middle, where you're eliminating coupling, you're introducing coupling as you make changes the behavior, but you're also eliminating coupling at a reasonable pace, whatever that reasonable pace is. So that's what coupling is. And this means the job of software design in this, showing off what I was, where was previous page? There we go. The goal of software design is to balance working on the behavior, changing the behavior, and changing the structure. Why do you change the structure? To reduce coupling for the changes that you actually make. One of the implications of that definition of coupling, two elements and a change, is if you never make this change, those two elements aren't coupled. So if you say, well, if we ever change database vendors, this is going to be really expensive because we have this knowledge of the database vendors scattered all through the code, and you never change the database vendors. It's like potential energy, but it never gets released. It never turns into actual costs. So part of the analysis as a software designer is what are the changes that are going to actually take place? Now, the style I'm advocating here, I call empirical software design. And I distinguish that from speculative software design, where as a software designer you think, let me think about all the changes that might ever have to happen, and I'm going to reduce the cost of everything I can imagine ever changing about this software. That's speculative. And some of those bets are going to pay off, and some of those bets are going not to pay off, and some of those bets are going to backfire spectacularly. And that's the one side of the trade-off I want to avoid, that speculative style. And then there's reactive software design, where you just say, I'm not going to change the structure until I'm almost dead. Because structure doesn't matter. All that matters is getting the next feature out. And that one ends up costing way more over time as well. And I had to come up with a word, so I chose